If you feel any difficulty in reading an electrical diagram or troubleshooting a circuit, so this video will help you in rectifying these issues. So this is a simple circuit where we can see vacuum fan number 1 and vacuum fan number 2. They both are connected in parallel. Suppose these fans are not running. So how we will start? We shall start from the beginning. Here you can see L1 and N. So it could be 120 volt in North America and South America and Europe, and it could be 220 volt in Asian countries and in the Middle East. Okay, so you will use a multi-tester. So in the multi-tester, black probe will be connected here, or if there is a terminal, otherwise here anywhere, because black is common. And red probe will check here at this terminal will check. And here I show you, if you want to check supply, we select DC, and these are the probes. Okay, one is connected at positive, you see the V voltage, and black is common. So when we want to check 24 volt DC, we'll select the voltage and DC, and then you can see here it shows negative. And then we need to check like this one, we want to check the supply, we'll connect negative here, positive here, then we'll check the voltage here anywhere, because black is common. And red probe will check here at this terminal will check. If we get supply voltage here, let's say suppose 120 volt, then next step will be, this is what is this? This is the single pole circuit breaker of 4 ampere 36F1 single pole circuit breaker. So then we will check voltage here. Remember, black probe is permanent here. Okay, so red probe here we get the voltage, here also get the voltage. Then we connect that probe here. What is this? This is auxiliary contact of 36QA1. What is 36QA1? That is this one, the contactor, magnetic contactor. So suppose we connect here at number 1 and we are getting voltage, okay. But when we connect number 2, our probe we connect here, red probe, we don't get 120 volt. It means we have issue, because this contact is normally open, it must be closed. How it will be closed? As soon as this contactor is energized, then we will have this closed contact and supply will pass. Remember, this contact also belong to this contactor. Okay, both. So then we'll leave it here, because we found it that we verified that supply is here up to one terminal, up to terminal number 1 is okay, but we are not getting supply at number 2, means this contactor is off. When we come here and we see A1, A2 are coil terminal, supply terminal. Here we see on off switch. Suppose maybe the on off switch is at off position, a 0 position, that's why it's not getting on. But maybe the switch is at 1, means the contact circuit is closed, but the contact is defective. So same black probe will be here, we connect the positive probe here, supply voltage 110, okay. But when we connect here, oh, supply is missing, means our selector switch normally open contact is defective. So we'll just, I show you the contact already, so we will just change that contact and our problem should be solved. Okay, suppose contact is okay, our contactor is on, but still our circuit is not running. When we check physically, we connect meter here at A1 and A2, A2 negative probe, A2 positive probe, and we get 120 volt AC. It means the contactor is on, we are getting supply. Then again we see contactor is on, but when we connect our positive probe here, still we are not getting supply. It means this contact is damaged, this contact of this magnetic contactor. So we will change that contactor, and then definitely our problem should be solved. Because after changing this, when we put the selector switch at on position, the contactor is on, we check supply here, we connect our positive probe here, negative probe here, we are getting 120 volt, our problem is solved. Because after this there is no interlock, it's going directly to the motor. So this is a simple way how we check the how we troubleshoot troubleshoot the problem and how we read the diagram. I hope this video will help you. And please subscribe my channel if you think that this video helps you. Thank you very much. This is the circuit breaker, single pole circuit breaker, and you can see it's a 1 ampere, and this is the terminal incoming and this is outgoing. So this is called single pole circuit breaker. We have different kind of circuit breakers like a single pole, this one, then we have a two terminal, double pole and three pole for three phase supply. And then we have these called terminals. You will also see in the diagram terminals where we connect the different wires. So make sure that it should be insulated like this one. Don't ever fix like this, it will be shorted. So be careful. You can see the groove here, it should be identical. So these are called wire terminals. Then these are the auxiliary switch, on off switch, and NC means N normal close, NO means normally open. So here we have different kind of options, like this is the push button, you can see. Sometimes we fix a selector switch here, a knob, on off knob. So these are the push button contacts. Another thing, this is called contactor, and I would like to explain. You see DC24 A2 and A1. So these two terminals A1 A2, where we have DC24, this is called coil or supply terminal. This is a coil terminal because it has a coil inside. Okay, so that energize, it's a magnetic contactor. So these are supply terminals. Then we have different terminals like 1 2 3 4 5 6, and this one is the auxiliary contact. Okay, these all are open contacts. I will show you in the diagram. And we have additional terminal block also. This is not for this contactor, magnetic contactor, but I could find only this one. But this is additional contact. If we need some more contact that we use in circuit, we fix it here.